In this video, we're going to focus on some skills involving surds. The first one that we're going to look at is simplifying. If I need to simplify square root of 12, I need to think about numbers that I can multiply to get 12, and I want one of those numbers to be a square number. So in this case, I could write square root of 12 as square root of 4 times square root of 3. Now I can square root 4, which is 2, so my final answer will be 2 root 3. In the next example, I can write square root of 8 as square root of 4 times square root of 2. Again, I can square root 4, and that is 2, and we keep root 2. In my next example, I can try and simplify what I've got here first, and then calculate, or I can multiply those two numbers first and then try to simplify. I'm going to do the latter, so I'm going to multiply the two numbers first, okay, and that is 48. And now I need to think about what number, what square number will be a factor of 48. So what two numbers can I times to get 48, and one of them needs to be a square number, possibly the biggest possible. So the biggest square number that is a factor of 48 is 16. So 16 times 3 gives us 48. So I can write square root of 48 as square root of 16 times square root of 3. Now I can square root 16, and that is 4, and we keep root 3. In my next example, I can divide the two numbers, and that is simply square root of 6. In the next example, I simplify first. So square root of 300 can be written as 100 times 3. Okay, so square root of 300 can be written as square root of 100 times square root of 3. Okay, and then we take away, and then we simplify square root of 12. We've done this example already. I know that's going to be 2 root 3. Okay, now square root of 100 is 10, so I've got 10 root 3, take away 2 root 3. Now because the roots are the same, I can actually take away, so that's going to be 8 root 3. And in my final example, I need to simplify the surds. So I can write 54, square root of 54, as 9 times 6. So square root of 9 times square root of 6. Then I take away square root of 6, and then I add, and I can write square root of 24 as 4 times square root of 6. Okay, now as you can see, okay, I've got square root of 6 appearing a few times, so I'll be able to simplify later on as well. So I've got square root of 9, which is 3, so that's 3 root 6, take away root 6, and then I add, and I've got square root of 4, which is 2, so that is 2 root 6. Okay, and then when I calculate this, that gives me 4 root 6. Another skill I would like us to focus on is expanding. And expanding involving surds works just like expanding in algebra. So I have to multiply everything from the first bracket by everything in the second bracket. So I'm going to start with 2, and I'm going to times 2 by root 3, and that is 2 root 3, and then 2 times negative 1, that is negative 2. Then root 3 times root 3, okay, that is going to be root 9, and I'll be able to simplify this. Okay, and then take away, I've got here root 3 times negative 1, so that is negative root 3. Okay, so now I can simplify those surds here, and that is going to be simply root 3. Now remember that root 9 is 3. So I have -2 add 3, which is +1. In my next example, okay, I've got algebra as surds, okay, or we've got surds in algebra. So I'm going to expand the bracket. So I'm going to times root a times root a, that is simply a. Then root a times root b, that is positive root ab. Then negative root b times root a, that is negative root ab. And then negative root b times root b, that is negative b. Now notice, okay, that I can simplify this part here. Okay, this will actually cancel, and what I have left over is a minus b. And that is very, very important that we remember this, because we're going to use it when we have to rationalize denominators. So let's have a look at how rationalizing denominators works. So when you have to rationalize the denominator, it means that you don't want to have the surd in the denominator. So in my first example, I've got root 3 as my denominator. So to get rid of that denominator, I'm going to times this denominator by root 3. Okay, but remember, we want to keep the value of the fraction the same. So whatever I do to the denominator, I have to do the same to the numerator. Okay, so now I've got 7 root 3 as my numerator, and then root 3 times root 3 is root 9, and I can square root it, and that gives me 3. And I have no longer, I don't have a surd in my denominator anymore. In the next example, again, to get rid of the square root of 2, I have to times by square root of 2. But again, I'll have to do the same to the numerator. Okay, I have to times it by 2. Now, by root 2. Now, I would normally write the root 2 in front of the brackets, because it's just easier than to expand. So I could write this in this way. Okay, and now I'm expanding, so that's root 2 times 1, which is root 2, then root 2 times root 3, and that is root 6. And then I've got root 2 times root 2, which is root 4, and that is simply 2. And in my final example, the final example is more complicated. Okay, I have slightly more complex denominator, and then to make sure that our surds cancels, or we get something that we can actually square root, what we need to do here is times by the same thing but with the opposite symbol, and we must have the opposite symbol to make sure that those surds cancel. And we had the similar situation in our previous example, in our previous slide, when we were expanding brackets. Okay, I need to also remember to multiply the numerator by the same thing. So I need to now expand. Okay, so 2 times root 7, that is 2 root 7. 2 times root 3, and that is 2 root 3. And what we learned from the previous slide is that when I expand this, all I'm going to have left is 7 take away 3. Okay, so now I've got 2 root 7 add 2 root 3 over 4. I could also simplify this, okay, by dividing the numerator and the denominator by 2, or in other words, I can simplify this fraction. If I factorize the numerator, I can write this as 2 root 7 plus root 3 Okay, so this is what we had at the beginning. Okay, and then over 4. And I can divide the numerator and the denominator by 2. So I have root 7 add root 3 over 2.